Hello, everybody, and welcome to episode 89 of Community Service Hour. Today, we have an episode about message signing. This is some stuff you've got to know when you're using a wallet for Web3. Also, we've got a drink of the day. Here we've got Simi, a Pinot Noir from Sonoma. Compliments of Sizzle. Thanks, Sizzle. So we'll get that. Open that one up. Nice, pour that. That is perfect color for Pinot. All right, today's message signing. So everybody does it. It's free. There's a thing about that. If it's free and everybody likes it, there's usually a what if or a warning or something. Titled, what is the worst thing that can happen if I sign a bad message? And if you don't know what a message is, it's this box that comes up. So this is a signature request, also called a message. Same thing for a transaction. When there's a transaction, you got to sign that too. I mean, they both have a blue sign button, right? But basically, you're doing a thing that's cryptography and connected to your account. Let's talk about this.
I know logins typically have it, and I was actually even considering using this feature for like 2FA. So like if someone logs in and then they're prompted with like, oh, this wallet pop-up to like sign like some sort of nonce. For that specific use case, the way I have it currently set up is there's actually just a normal login and it's just like an email password. I actually hash both of those things. I don't even have like the email in the database. And so
Stop. Can we just applaud you for a moment on that? Okay. Can we applaud you for hashing the email address before you even put it in the database?
Yeah, and there is caveats with that, of course, right? Like if I have a data breach, it's going to be hard for me to contact the emails, of course, like in the database. But at the same time, there's also nothing worth stealing to begin with since it's already hashed. And I also do a little bit of peppering too. This is a very uncommon thing. So instead of salting where you store the salt, what I do is I actually generate the permutations like right then and there for like this extra little nonce that I already know what it is. And then I also, this is also not normal, but I also chop the hash too, because I know that the first few like bytes of the hash is good enough. Like I don't need a full hash comparison a lot of the time. I think what the proper word for this is k-anonymity. It's a form of it. And yeah. And so on top of this, like I've looked at other 2FA methods already, like authenticator app, YubiKeys, stuff like that. For my site, I also do like it is like a hybrid Web3 site, and I was like, you know what? Why don't I, instead of even doing an authenticator app, if everyone's already using a wallet, that would be a really good 2FA mechanism.
Beautiful. All right, I'm just showing off real fast. This is tbone.ai, and just showing you the database schema. This is the same exact thing. We do email salted SHA. This is best practice. Nobody's doing it. Props on that. Something else that what I like about what you're saying is that using it for two-factor, you shouldn't be logged in all the time on your wallet. You shouldn't be walking around with your private key. And so if you're using it as a second factor, then you can cache it or you can make a cookie or whatever. This is good stuff.
Yeah, exactly. Yeah, on the site, I don't require them to always sign in with their wallet at all. Yeah, and if they don't want to use that 2FA method, they're more than free to use like the authenticator app implementation, but they still have the ability to like store their public key and verify against it. Yeah.
So thanks for sharing. This is one very good use case for messages. There's a second big use case for signatures.
Action. Like if you want to perform an action of some sort, I can see like the message having that action in it, maybe with like a nonce or something.
Wouldn't one of the actions be like when you're on OpenSea and you're trying to list an asset that you minted on OpenSea? Wouldn't you just sign it?
That's right. Your signature is authorization to transact on your behalf. Primarily, what's going on is one person signing, one's a maker, one's a taker. Okay, so those are the two use cases. Kind of expanding these two definitions just a little bit. So logging into a website, another thing you could do with a message kind of to that regard is that you can send an email. So what you do is you would sign a message and you would encrypt it. You'd encrypt the message for the recipient and then you would sign it after that. And then it goes through the Web 2. The recipient gets it and then they know who sent it because it's signed. And then they can decrypt it because it's to the benefit of their private key. And then they get the message. You're doing the same thing for the website. You're giving it to them. You're sending it over HTTPS, which is a form of encryption, not across the Web 2 sphere. And the thing that you're sending is signed proving that you want to log into a website. All right, so that was kind of just expanding the first point. The second point is it's not just about transferring NFTs and buying and selling crap, but you can also perform arbitrary transactions. And really, there's not much else done on blockchains other than buying and selling tokens. We'll just say it anyway. If there's something you really wanted to do, but you don't have Ether, then you could perform the same action by just signing a thing and then using a relayer. This is something that's been kind of built out by OpenZeppelin. This is kind of an assumption that's built into all their projects, this relayer concept. And I haven't really seen many people using it, but it gets built in everywhere and then eventually gets used, where the transactions work, whether you sign them or you pay the gas yourself. To my understanding, these are the only two use cases for messages.
So is there ever a transaction involved in a message, or is that the difference between sending a message and listing an asset on OpenSea like that? That one of them involves a transaction, the other doesn't? Or do both of them involve it at some point?
If the goal is to do commerce, then the message will eventually settle on a blockchain.
Okay, but that's separate from the message itself.
Let's say you're buying squares. One person has a square, they list it on OpenSea, and they create a message. They sign a message, I want to sell this square for 20 Ether. So the person that wants to buy the square, they're going to take that message. So the taker is going to have to go to the smart contract, and the taker is going to say, hey, I want to buy that thing. And the smart contract is going to say, well, who's selling it to you? And then the person's going to say, that guy over there says he wants to sell it. And the smart contract says, well, he didn't tell me that. It was not previously known to the smart contract that this person wants to sell it. So then the buyer's like, well, I brought this signed check right here. It's signed by that other guy, and it says that he wants to sell this to me. And the smart contract's like, I don't believe you let me see that. It picks it up, reads it, and it's like, okay, you're cleared for transit.
Interesting.
So eventually that message does hit the blockchain.
The message is interoperable with a future transaction. It's not just a standalone thing forever.
Correct. Very, very much. I'm looking for edge cases here. Eventually it has to settle. I'm even using the word message to describe Bitcoin Lightning Network. Even Lightning Network messages eventually have a threat of settling on Bitcoin. Even all layer 2s have a threat of settling on L1. So in this case, the message is a claim against, I don't know if it's a claim, but it's an offer against.
It's basically credit, the Lightning Network, my understanding.
Yeah. But that does not include logging into a website. Okay, so now that we know what a message is, I want to say that basically anything you can do with a message could be done more expensively using a transaction. There's just a couple special things that a message can do that a transaction cannot do. So I want to highlight these. These are also what make the messages more dangerous. Number one, a message can be used multiple times by default. There's not necessarily a restriction against using it multiple times. Now, if you don't want that feature, that's fine, but you have to add that feature in. For example, OpenSea doesn't have that problem. OpenSea, if you sell something with a message, you can't sell the same thing on the same message again. The message expires. There's a nonce where you could make a second message, but the first one ends at the time that you use it. This is a concept, right? So this is a concept that applies to messages on smart contracts, but it also applies to signatures against zero-knowledge proofs. This is called malleability. So you got to watch out for the Groth 16, because if you sign one message, you could actually use it multiple times. There's a whole thing about that. There's the plus minus parity bit, and then there's the multiplicative factor, right? So you watch out for that. Now again, practically, this doesn't matter on OpenSea. This doesn't matter on Rarible. They already thought of this. But if you're making stuff with this, or you're using something that's not OpenSea or Rarible, or it's on a different one, it's on a totally different blockchain, or it's on Bitcoin, or that's something you want to think about.
For sure.
You want to ask them like, hey, did they think about this? Also, these projects, these are bridges that are made by people on very low budgets, late at night, and they got big fast. Those are the people that are, those are the people that are guardians of the Triforce. So watch out for that. All right, second note here. So messages can be played out of order. Transactions, by default, have an order to them. If you submit 2 transactions, the first one has a nonce of 1, the second has a nonce of 2, and the second transaction is not effective until the first one runs. In fact, you can hack this technique a little bit. If you make a transaction for 1 and you don't want to broadcast it, if you notice in Wallet, sometimes there's a cancel button. What it does is it runs another transaction with the same nonce, and it runs that one first. It tries to pay a higher fee so it gets settled faster, assuming that there's no mempool watching, assuming that there's no MEV going on. That one will settle first, and your other one will fizzle. Messages don't. If you sign 5 messages and you put them out there, they can be played in any order. So this is not a good thing, it's not a bad thing. You know, it's a feature and a bug. But by default, this is not something that messages do. Now, you could have a smart contract that reads this functionality into it. For example, you could require nonces, and you could require that these things be settled sequentially. It's fine. It's just that you don't get that by default. So it's something you got to know. Okay, there's a third and final thing. A message that you sign on Ethereum works on Tron. Something that works on mainnet works on testnet. Something that works on Avalanche, you know, these things are all connected. Again, there's workarounds for this, but by default, these things are not controlled. EIP 712 is a way to compensate for this. So you can include the chain ID, or we call this a domain. So you can include a domain with the message that constricts it to one specific network or chain or technology or something. But by default, messages don't have that. So if you take a message and you don't allow it to be used multiple times, and you don't allow it to be executed out of order, and you only allow it to execute on one chain, well, basically you've just reinvented transactions.
Where do the messages exist? Do they? It sounds like they're fundamentally off-chain.
Yes. Messages are off-chain.
Okay, so you're basically using a blockchain instrument for its cryptographic abilities, and you're using the cryptography, the encryption, outside of the blockchain itself.
Perfect. And in fact, that's one of the best use cases of blockchain, is not using the blockchain. It's just using the public key cryptography.
Word. Like HTTPS, like you said.
Right. You can take PDF files and sign them with Ethereum. It works better than actual PDF signing, which you totally shouldn't use because it's been hacked. The most dangerous part of the message is you don't know where your message is. You give it to a website. Is it in a database? Where is it? Here's my guess. Wild guess. Wildly uneducated guess. OpenSea, a lot of people have signed messages to buy things and sell things, and they send it to OpenSea. They're in a database somewhere. They're on a tape backup of OpenSea somewhere. Those messages are worth more than the rest of the company combined. All somebody's got to do is go into the tape backup of OpenSea. You know, People was for sale for 69 million, something like that, 72 million. Somebody else wanted to pay 58 million. That was years ago. Maybe it's worth 10 million right now. Maybe the 58 million offer is still valid. They just forgot about it. It's not listed on the website. And maybe the other person wants to sell it for 10 million right now. So all you got to do is buy it from them for 11 million, sell it to the other guy for 58 million, pocket the difference, and then do this for every single NFT on every network everywhere, and just pocket all the difference. That delta right there on these buy offers and sell offers that are already signed is probably worth more than the entire company combined. Now, they're old versions of the marketplace. They're probably paused. You just unpause the marketplace, run all these transactions through, and retire like a billionaire. Okay, so this is the perspective of OpenSea. What about the perspective from you, the person who could be out millions of dollars for all these things all these messages that you signed over the years? That's the problem. That is the problem. You signed these messages and you forgot about them. You just wrote checks, you gave them out, and you forgot you wrote these checks.
Checked your balance.
You got to write it down. On the front page of the checkbook is you write these things down, and you're like, okay, and you cross them out when they get cashed. So I wrote a check for 1,000, and when it's cashed, you cross it out. Every time you write a message, unless it's logging into a website, that's a commitment that somebody could cash against you whenever.
Great way to put it. Interesting.
Now, that also means that if you're broke, if you've got no money, if you're Will Smith and you write a check for $1 million, he wrote himself a check for $1 million when he didn't have it, saying, I'm going to be famous, I can cash this check one day. And even if you don't have money and you write a check for $1 million, if you give that check out and then you get $1 million, somebody can cash your check. Same thing. If you sign one of these pop-ups on a website, if you ever previously signed one of these pop-ups and you didn't know what it was or you just clicked on it and the pop-up said, take any NFT that I have and sell it for $0. But back then you didn't care. You didn't have any NFTs. You were like, I only have 0.01 Ether in my account. And you looked at it, you're like, okay, I don't care. I can click anything. There's no risk because I have nothing. But then later you start getting paid in that account in Ether. Well, again, watch out for that.
Is there really no way to counteract that by having like a message appear on the blockchain network?
That's perfect. It does not necessarily exist. So it typically does. So OpenSea has a way to disavow messages, and the disavow method is different in different places. Also, sometimes the messages is just like 0x1248b2. It's opaque. You don't know what that message was. Well, maybe that message was to sell all your NFTs for 0 Ether. But you can't cancel that because you don't even know what it was. That's a blind person signing a blank check.
Hmm.
The only thing you can do at that point is if you knew which wallet signed it. So the blunt approach is that you can just stop using that wallet. The way to avoid this, kind of the quote solution here, the wallet should just have a checkbook, have a ledger of everything, all the messages that you sign. When you sign a message, there should be a message history. And there should be a list of all your messages.
It's a really significant problem. That's wow. I didn't think of all this. I think a lot of people really do need to know about what you're talking about.
A lot of people know, and unfortunately, the people that don't know that learn, you either learn the easy way or the hard way.
This problem that like you're describing, where you like hold on to the signed transactions, it's funny because like long ago in the PGP ecosystem, this was like a huge problem, and it still is today, right? Like people sign so many messages, they don't track them, and then like years down the line, someone can easily prove that there's someone they're not by just replaying those same exact messages because they didn't include timestamps, they didn't include nonces, nothing that would lock down the validity of when this signed message expires.
Yes. So if you sign a message that says, I am Will, and you show that message to anybody, then anybody has a message that says, I am Will.
Cool.
And, yeah, and then that key just becomes useless because anyone can do that now.
Yeah, that's actually the article. That's my next article is going to be based on this too. Okay, so here's the next step. Is that our.gg now has badges. You know, I want to recognize everybody who's part of this. You're showing up, that's cool. You're presenting, that's better. You know, we'll also have the bounty board. We've got all the names, we just need the faces. And then you'll get like a number or something with badges. So there's badges. This is an experiment. You know, who knows if this is the way to run a community or to participate in a community, right? Have badges and whatever, but just in the spirit of blockchain, in the spirit of Web3, in the spirit of the future, in the spirit of openness and recording permanently things, I recognize your participation in joining this call. Because the whole point of this, you know, we don't just do blockchain because we like NFTs on OpenSea. We don't do that. We do blockchain because we have a view of the future.
Oh, cool! So you have a repo already set up with the code, and we can all.
Yeah, man.
That's awesome.
It uses Jekyll. I mean, it's pretty clear how this stuff works. The last thing. So last week we met with Diana, talking about crypto marketing and influencer marketing with Binance. Totally different program. Just randomly, it was the Amazon Creator Connections, and this is exactly the type of program that Diana was describing for Binance. Except it's done on Amazon, and then instead of selling tokens, you're selling, you know, other stuff. The brands contact you. So you make a profile, you're like, here's what I can do, here's what I'm interested in, and then theoretically you should start getting hit up. So I went in there, I'm like, here's me, here's the things I'm interested in. I'm interested in clothing and technology and home goods and this, and I do photography. Apparently brands are maybe gonna contact me, and then you decide which ones you work with, and Anchor might be on there. That's cool. I like Anchor. So we want to replicate these models, in crypto legally. I've seen a lot of partnerships and promotions inside crypto projects. I don't want that. I want to see something that Amazon's doing, copy pasted into Binance. I want to study these models. That's how I do a good job as an advisor. I want to bring these techniques over and then make sure the crypto projects are doing legal things that are effective and, work